I hear from lots and lots of students that they're scared of Excel. So we don't want to be scared of Excel, do we? It's just a tool to solve a problem. That's ultimately what Excel is. So we need that theoretical knowledge of how to solve the problem, which is the starting point of it all, and then we're going to use Excel as a tool to make our lives easier in solving that problem. So Excel shows its face really on the level 3 management accounting techniques unit. So tasks 5 and 6, 2 16-mark questions, so 32 marks out of the 120 on the management accounting unit are related to Excel. And there's various things you need to be able to do as part of that, some of which we're going to look at tonight. I could literally talk all week about Excel. We could spend all week looking at this. We ain't got all week. We've got an hour and maybe a little bit more. So we'll look at some elements of it, and then I'll come back in the future and do another session looking at some of the other bits that we don't look at tonight. So the key thing for me is if you can master Excel, you can turn your accounting data into useful decisions, which is at the heart of management accounting. Being able to transform data into information, make the information useful, and then build knowledge that informs decisions. And that's what management accounting is all about. So what we're going to look at this evening. So it's a lesson. One who's prepared earlier. It's not a lesson as such, it's just but it does have some objectives. So I want to try and teach you or show you this concept of absolute referencing. It's probably one of the least understood concepts that I certainly see when I'm teaching this, is that people write the formulas once, and then they write it again, and they write it again, and they write it 6, 7, 8, 9, 10 times, when actually you only need to write it once. So we're going to look at the difference between relative referencing and absolute referencing, and master the distinction between the two. Look at, I've called it logical gateways, but ultimately looking at the logical operators in Excel functions. So can we construct things like if statements? If this happens, do this, otherwise do something else. So can we do that? And then we're going to get a little bit more complicated and try and nest our functions together. So can we do if this happens and that happens, do this? And can we do if this or this happens, do that? So what's known as conditional outcomes. So use some Excel functions to construct some logical test. So we're going to look at some of that. Then I'm going to introduce some data retrieval techniques. So we're going to utilize this thing called VLOOKUP, so vertical lookup function, to be able to extract cost from one Excel worksheet into another. So look up the values and pull them into another worksheet. So we're going to look at some of that. And then we're going to construct some very, very basic what-if model. So what will happen if this happens? So, for example, if inflation goes up to 10%, what will happen to our cost? Just in a simple case. So that's the sort of thing some of the stuff we're going to look at. We do have, I think, well, hopefully you've seen the files that I uploaded on the group, which I'll try and put in the chat if I can. Oops. So, what's going on here? Yeah. So you've got some files that I uploaded earlier, which we're going to work through as we go through this. So why use spreadsheets? So I think before we sort of dive too much into Excel, why bother? Well, really, it's about mitigating risk. So the more things you automate, you get rid of a certain amount of risk. Yeah, so calculating, as it says, calculating extensive standard costing models or cash budgets by hand is inherently risky and highly prone to human error. If we can use a structured spreadsheet to act as that automated ledger, essentially ensuring mathematical integrity across thousands of rows of data, we do two things. We reduce the risk of us not being able to add up properly, reduce the risk of us, not having the right numbers in the right place. And we also increase the speed of reporting. Just think about how quick we could report using a spreadsheet against how long it would take us to, report 1,000 rows that on a piece of paper. It would take us far longer to report on the human written pen and paper approach than it would in a spreadsheet. So first big concept we need to be able to get our head around when it comes to Excel is the difference between formulas and functions. So formulas, any calculation that's designed manually by the user. And can utilize, doesn't need to utilize, but it usually does utilize standard mathematical operators. So addition, multiplication, subtraction, division, to calculate a result directly between some specified cells. So my example that I've got there, all formulas and, for that matter, all functions start with equals. So we'll look at this when we look at some examples in a little while, but equals A1 plus B1 takes the contents of A1, the cell A1, and adds it to the contents of cell B1. Now that's great. That's one way of doing it. But that is designed by me, the user. So that is very much designed by me. It's not using any functions built within Excel. A function is a predefined calculation built into Excel and can perform simple or, in some cases, complex operations quickly by evaluating data ranges according to some underlying syntax rules. So one key function that we've got in Excel is a function called sum. So what sum does is it takes a range of numbers and adds them all together. So what we've got here is equals sum A1 colon B10. So what that will do is take all numbers in the range A1 to B10 and add them all together. Now, A1 to B10 is ultimately A1 to A10 plus B1 to B10. So 20 numbers. Yeah. Now we could have done A1 plus A2 plus A3 plus A4 plus A5, so on and so forth. How long's the formula? Quite long. Yeah. Using a sum function, sum A1 to A1 colon B10, 20 numbers. Yeah, add it really quick. Now we could do A1 to B2000. And now we've got 2,000 numbers. Or 4,000 numbers even. Yeah. But we're not having to put A1 plus A2. We'd be there all day if we did it that way. So the functions are really useful because they're predefined algorithmic calculation. We know exactly what we're going to get from that. Yeah. So we're removing an element of human error in that we know what sum's going to do. It's just going to add those numbers up. So we should probably use functions rather than formulas, but typically we use a combination of the two, depending on what we're trying to do. Now, something that I think is really important, but then, you know, it comes with a big caveat, that thing right written at the bottom of that slide. So you'll see lots of people talk about, and I'm going to, on the next slide, we'll talk about in more detail about absolute referencing and relative referencing. And there is the core rule is that we want to lock our variables in some cases, which we will look at. And the way we do that in Excel is using the F4 key on the keyboard. That is probably the most critical shortcut you're going to use in Excel, especially if you're a management accountant and doing some management accounting modeling, because you're going to want to lock your cells at certain points. And what F4 does is it toggles your cell referencing between what's known as relative referencing, where the references move as you drag down the page or to the left and right. Toggles between that and what's known as absolute referencing, where the cell references are locked. So if you drag the formulas down or left to right, the references don't change. Yeah. So the way we can do this is highlight the cell reference in the formula bar, which we'll look at when we look at the examples. If you press F4 on the keyboard, and instantly you've got absolute referencing. And then you can drag your formula down the column or across, well, down the rows, sorry, across the columns, and it will be fixed. Now, the most important thing to remember, and the thing that I spend a lot of time telling students is, this is all great, yeah, but it does not work in the AAT maths exam. The function keys do not work. So it's important to understand how to do it in the real world, press F4, but it's also important to understand what pressing F4 does and how we can manually do that in our exam. Which brings me to the next slide. Oops. So relative and absolute referencing. So just 3 examples here of what's known as, well, relative referencing, absolute referencing, and then mixed referencing. So the default state when you select a cell as part of a formula or a function, its default state is that it will be used relative referencing. So as you can see, just A1. A1, that's just relative referencing. Now if I drag the formula down the page, A1 becomes B1, sorry, A1 becomes A2, A3, A4, A5, A6, A7. If I drag it to the right, it becomes B1, C1, D1, E1. Might be what we want. And in quite a lot of cases, that is what we want. But in a number of other cases, it's not what we want. Yeah. So what we might want is absolute referencing, yeah, or the so-called anchored state. Yeah. So adding $signs before both the column and the row. So the column being the A and the row being the 1.
Showing it. Okay, then it's not showing it.
You're not seeing my screen, the slides. Yep. So adding a $sign before the A and before the 1 locks both the column and the row. So if I then drag my formula down or left and right, it will stay locked on the cell A1. Now that might be what we want in some cases. And then the third option you've got is what's known as the hybrid state. And the example I give here is where you want the columns to stay the same, but you want the rows, you want the columns to change, sorry, and you want the rows to stay the same. So rows 1, 2, 3, that's staying fixed. The rows are staying fixed. The columns are changing. So if I drag it down, yeah, it'll just be A1, A1 all the way down. Yeah. If I drag it to the right, it'll become B1, yeah, C1, so on. So the row is locked in place. The column remains relative, free to move left to right. So you've got a combination of relative referencing. So we've got relative referencing on the columns, and we've got absolute referencing on the rows. So it's a mix of the two. Now we'll look at why you might want to do that as we look at the examples in a little while. Just a little bit of information about the F4 key. Some people find this useful, some don't. First time you press it, it applies full absolute referencing. So it will go from relative referencing to absolute referencing. So both column and rows are totally absolute. Press it again, it applies row lock. So the columns become relative, the rows become absolute. Press it again, it shifts the other way. The column becomes absolute, the row becomes relative. Press it again, and you go back to completely relative state. It's quite useful to know, especially if you're pressing F4 and wondering what's happening. That's what's happening. Yeah. Right. So that's just a little bit about the difference between functions and formulas. So we're going to dive a little bit into the formula world. Into the function world. The functions we've got then, we're going to look at rounding functions to start with, because these are used right across the AAT maths exam. They are used extensively, and there's 3 of them: round, round up, round down. And believe it or not, they're not all the same. They don't all get the same answer. They are very different. The questions in the exam will say, sometimes they use quite specific things like please round up, please round down. And in other cases, they say round appropriately, where you might need to exercise some judgment around which of the rounding functions you need to use. So round takes a number and round it to a specific number of digits using mathematical rounding rules. So literally take a number and round it to the nearest number, the nearest 10, the nearest 100. And we'll look at the syntax for doing it in a minute, but take a number, round it using mathematical rounding rules. Round up forces a number to always round upwards. So forget mathematical rounding. 19.3 becomes 20. Yeah, so it just forces it to round up regardless of mathematical rules. Yeah. Now that's quite useful for things like break-even points. So if you're trying to calculate break-even points in units, and let's say you calculate it and it comes to 212.25, you can't have a quarter of a unit, can you? But if you don't do that quarter of a unit, you've not broke even. So actually, you need to round it up to the next whole unit. So round up is quite useful for things like that. Round down, there could be cases where you want to do that. Maintain conservative revenue commission estimates is one example. But what that does is forces a number to round down. So you might have 19.7. 19.7, if we used round, would get us 20. Round up would clearly get us 20. Round down would just round it down to 19. Yeah. So it forces the number to truncate itself down towards 0. All really useful things to do, and something that you're definitely going to need to know how to do as part of the exam. There will be questions where you've got to do different types of rounding. So a bit of an example there, standard rounding, and then I've got a round down example on the right. So if we were calculating commission, and we calculate it using some formula of some sort, and we get £42.85, then we could round that to the nearest pound. Yep, so if we did equals round whatever the cell containing the £42.85 is, or we could put the number in if we wanted, comma 0. Now the comma 0 says, well, I just want to round this to, with no decimal places, right? I want to round this to the nearest number. Yeah, and obviously using round, 0.85 gets rounded to the nearest number, the nearest whole number. So in this case, 43. And then what we could say is, well, we don't want to use standard rounding. We want to round commission down. And so the business maintains the fractional margin. So we might want to round £42.85 down to 42. So we can do a very similar thing, but equals round down the cell that contains the £42.85, comma 0, and that will round it down to the nearest whole number. Yeah, which £42.85 becomes 42. Now, it's out of the scope of what I'm looking at tonight, but what I would recommend people play with Excel. If you you can start doing things in there, like you could round down the cell, and instead of putting 0, put -1. What that'll do is round it to the nearest £10. So instead of the nearest pound, it's the nearest £10. Yeah. And you could go the other way, round down cell, comma 1, and that round to the nearest 10p, or round down to the nearest 10p in this case. Definitely recommend something to play with, because the question could say in the exam, please round this to the nearest £10, please round this to the nearest £100, please round it to the nearest £1,000. And you need to obviously be able to know how to do that. So there's some simple functions. Second bit of what I want to look at before I start looking at some examples is logical functions. Now, this is where we start to get into the real power behind Excel. So we can do things like automated decision making, which is a big part of what we might want to do. So if this has happened, so if this is true, do that, otherwise do something else. And that's at the heart of all of it, is this if statement. Yeah. So an if statement or an if function checks whether specific conditions are met and returns one specific value if it's true and another value if it's false. Yeah. So the syntax for it is all formulas start with equals. So equals if, brackets, some logical test. Now, what we mean by a logical test is something that can be evaluated to either true or false. So it can't be maybe true, maybe false. It's either is true or it's false. So 1 equals 1. Well, 1 does equal 1, so that's true. Yeah. So I've got an example there. Is sales greater than £50,000? That's a logical test. It either is greater than 50,000 or it's not. And then we need a comma. So that's the first bit of the function, comma, and then the value that is true. So what Excel should output if the logical test is true. And another comma, and then what it should do if it's not true, i.e. it's false. Yeah. So again, just the if logical test, check whether a condition's true or false. If it's true, do this. If it's false, do something else. Now, where it becomes really interesting is we can start to nest our functions together. Yeah. So we've got this another function called AND. So we might want to say, well, like I've got the example I've got down here. If we were trying to calculate, and this is all relevant to what we're likely to have to do in the examples that we're going to look at, if you company got a bonus structure that required both a high level of sales and a high level of customer satisfaction scores, and only if both things are true do we pay a bonus, then we might want to nest an AND function inside an if statement. So if, for example, if both we've got high sales and we've got high satisfaction, pay a bonus, otherwise don't pay one. Yeah. So what the AND function does is it demands that every single condition within the AND evaluates to true before it executes the positive outcome. And if any part of the AND function is not true, then it's false. Yeah. So it says this must be true and this must be true. If it is, do this, otherwise do something else. So it's really useful for stuff like the example there. If the bonus requires high sales and high satisfaction, you can do that quite easily with an AND function. What you also might have is an OR function. So this allows a level of flexibility. So the OR function requires only one condition within the parameters is met in order to trigger the true outcome path. So might be example there useful for flagging operational reviews. So you may say your HR team might do some sort of employee review meeting with staff if sales drop below a certain level or if sickness exceeds a certain limit. So now it's not both, it's one or the other. So if your sales drop, you're getting called into a meeting, or if your sales are really high but you've been off work for 20 days, you're also going to have to go to a meeting. So it's one or the other. Yeah. Obviously, if both are true, you're still getting called to a meeting because if any one of those conditions is true. So how do we do this? How do we nest the functions together? So the concept is that nesting involves placing one function entirely within another function. So what we want to do is place the AND or the OR statements that we've just looked at inside a logical test. Yeah, within the logical test parameter of the if statement. So similar to what I've got on the right-hand side there. So we've got the if statement, brackets, and then the AND statement, so and this and this. Close brackets. So what we're going to do if both of those two tests in the AND are true, we're going to do that bit. Otherwise, we're going to do the bit in the false statement. Yeah. A really useful thing to do. So you're going to say something like if and sales is greater than £50,000, comma, customer satisfaction is above 90%. And if both things are true, we're going to pay a bonus of £20,000. Otherwise, they're not getting a bonus, they just get the normal pay. Yeah. So we can start to build what are quite complex conditional outcomes yeah, based on complex test, but we can nest the test together. And that's a fairly simple example. But then you could nest another and within the, that test one could be another and statement in there, couldn't they? And you could build it up multiple layers. Starts to get complicated then, but there's nothing stopping you from doing that. So, time to have a look at some Excel then. So, I'm going to talk you through a little bit of slides, then we'll jump to the Excel. So, what we've got then is a practical exercise. It's a made-up company, Apex Retail. And this is what we've got. Now, all the files for this are on the group, which you should be able to find. I'm sure one of my assistants will drop it in the chat if people can't find it. But I think the data that you've got is these four employees: sales revenue, customer satisfaction scores, sick days. So data that's in the Excel file that we'll look at very shortly should look like what you see on the screen. And what we want to do is this, yeah? So the first bit of what I want to do is write some formulas in a bunch of columns, and I'm going to go to the spreadsheet in a minute. So 3 things: basic if. So if the sales exceed £50,000, output target met, otherwise output review needed. Second bit, our elite bonus. If sales exceed £60,000 and satisfaction's over £90,000, over 90%, sorry, award a elite bonus of £1,000. And then the third thing we want to do is a HR flag that says if satisfaction drops below 70% or sick days exceed 5, flag for a HR review. Yep. So let's jump to Excel. So one created earlier. Got a few other employers in here other than just the ones I put on the screen. Now, one useful thing to show you, you might see that, hopefully you can see the Excel. Let me see if I can blow it up a little bit. So you might see that we can't totally see all the employer names, yeah, and we can't quite see what that says in column in cell D1. So what we can do is we can auto fit the content to all the cells. So if you can press either Control A on the keyboard, that selects all the data, yeah, or you can manually select all the data. Or if you don't want to do any of that, top left corner where my mouse currently is, next to the A1, you click there, that'll select it all. And then if you just scroll your mouse between any two of these columns here, you notice how the mouse changes to 2 sideways arrows. If I double click there, it will expand all the content so that it auto fits. Yeah, so what we're going to do then? Well, a couple of things that I note, just looking at this, a couple of things that I would suggest if we were doing this out in the big bad real world. We might want to format sales revenue so that it looks a little bit more sensible than that. So we might, for example, want to format it with currency signs on, or with thousand separators. So in this drop-down box here where it says general, you can change the different formats of the contents of various cells. So we can go for currency, numbers. I'm just going to go for numbers. but I'm going to get rid of the decimal places. I don't care about the decimal places in this example. So when you click number, you automatically get 2 decimal places. Yeah, but then what it might say in the question is format as numbers, but with 0 decimal places. So what we can do is under the number, where we just selected number, there's a couple of numbers and arrows here. Yeah, one arrow that points left increases the decimal places. The arrow that points to the right decreases decimals. Press it twice, you'll get rid of all the decimal places. You might say, well, why you done that, Dean? You've got same as what you had before. Well, I did. But then let's say we want to format with 1,000 separators. Press the little comma there, that comma style, 1,000 separators. You get the same thing, but again, you've got decimal places. You might want to get rid of them. Yeah. Probably more importantly here is we've got a customer satisfaction score of 0.92. That's probably 92%, is it not? Yeah, so I might want to format these in a slightly more sensible way than 0.92, 0.85. So again, select all those numbers, and we can select the percent sign here, and by magic, they all become percentages. Yeah, 92%. So we've dealt with some of the formatting issues. There's loads of things you can do. You might decide to bold those, for example. So select all those, press bold. You know, we could be here all night looking at the various options for what you could do if you wanted to do. So the thing we're interested in then is, and you can follow along if you've got the files, you can follow along. Do exams use the most up-to-date Excel package? The simple answer to that is it uses whatever Excel your exam centre has got installed. Because what it is, it's a plugin that loads up whatever Excel is installed on the computer. So that's a simple answer. So you can follow along if you wish, but we're going to look at the first task. So a basic if function in column E. Yeah, and it says if an employee's target sales revenue is greater than or equal to £50,000, display target met, otherwise display revenue needed, review needed, sorry. So, a couple of ways of doing this. Now, the one thing I say to students that are not confident with Excel, yeah, is there's a big cheat sheet with Excel if you don't know what you're doing, or you're not confident with what you're doing. So up where my mouse currently is, yeah, hopefully you can see, there's this FX symbol about where the mouse is. If you click that, what you get is and it looks slightly different on a Mac. I'm on a Mac right now. Looks slightly different on a Mac to what it does on a Windows machine. But what it does, it brings up a formula builder. Mine's popped up on the right-hand side of the screen here. On Windows, it just appears in the middle of the screen. If you then select a particular function, so we know we want an if function, if I click on if, it then walks me through what I need to do. So we've got a logical test. So if an employee's total sales revenue is greater than or equal to 50,000, well, that's the sales revenue figure. Yeah, so I can just click on that. Yeah, so go back. Yeah, I could, in the logical test over here, I could type B2, or, you know what, I could just click on it. Let's just click on B2. Yeah, and then we're saying, is that greater than or equal to £50,000? So greater than is the sort of arrow that points to the right. That's greater than, yeah, or equals to £50,000. Now that's going to evaluate to true or false. Now, if you look at what top of the sort of screen here, where my mouse is, it tells me that that current logical test is evaluating to true, which is what we'd expect. 55,000 is greater than or equal to 50,000. Value is true then. We'll type in here, target met. Value is false, review needed. Oops. Review needed. Yep. And if you click done at the bottom there, that's it, it's done. Yep. Now, that's one way of doing it, using the formula builder. Another way of doing it is to manually type it. So equals if brackets, in this case, B3 greater than equal to 50,000, comma. Now, this is where students sometimes go wrong, because what they do is they type in target met, comma, review needed, close brackets. And they get that error. That's something that looks like that. Yeah? And it's because target met and review needed are pieces of text, are they not? Yeah. So they need to be in quotation marks. Now the formula builder will do that for you. But if you manually type it, you need to remember to do that. Yeah. So you need quotation marks around target met and around review needed. Now, I mentioned earlier that we want to type formulas once, not, in this case, 15 times. It's 15 rows here. I don't want to type the same thing 15 times. I want to do it once. Yeah. Now, we don't need any absolute referencing here. We're quite happy with relative referencing. The idea of relative referencing is if as we drag the formula down the page, yeah, the rows and columns are going to update. Well, not really bothered about the columns, because it's more about the rows. We're just going to go straight down. We're not going left to right here. We're just going to copy straight down. So what we can do is there's a couple of tricks. One is if we just, right at the bottom left right hand corner of that cell E2, if you just double click that, let me get rid of that one for a minute. Yeah, if you double click that, it will go all the way to the bottom. Yeah, so that's one way of doing it. Another way of doing it is if you select all the cells from there to the end, and press Control and D on the keyboard, that will copy the formulas down. Yeah, there's a couple of different tips for you. What you definitely don't want to be doing is typing the actual full formula in 5 or 6 times, or in this case 15 times. You do not want to type it 15 times. Remember, in the exam's 2.5 hours long. It's 32 marks out of 32 marks out of 120 for the Excel bits. So you're looking at about a quarter of the marks, a quarter of the time, 2.5 hours. You're looking at what? 40 minutes maybe for the Excel stuff, 45 minutes. You ain't got time then to be writing that formula 15 different times. You want to do it once. Any questions about how we write if statements? Feel free to stick anything in the chat or just shout up if there's any questions. Right, so that's the if statement. So you can see we've got some stuff where the target's met, we've got some stuff where a review is needed. Review is needed, everything less than 50,000. or less, yeah, less than 50,000. 50,000 or more, so equal to 50,000 or more, targets met. Second bit of what we're going to do then is nest some formulas together. So we're going to do a formula here to work out whether or not we need to pay an elite bonus. Now, the elite bonus is worked out based on if the employee has sales of more than £60,000 and a customer satisfaction score of 90% or more. And if it have, we're going to write a formula to output £1,000. If not, we're not paying an elite bonus, and the answer for the elite bonus is 0. Yeah. So first thing we know, we want an if statement. So I'm going to write this one manually. So if brackets logical test. Now our logical test is, does this employee have sales of £60,000 or more? Well, more than 60,000. I think it says, yeah, it does, over 60,000. So do we have sales over 60,000 and a customer satisfaction score of 90% or higher? So what we're going to do then is we need an and, don't we? Because we've got two conditions there that both have to be met. So it's not one or the other, it's both of them. So our logical test is this true and is this true? So we've got an and statement. So we're going to do and B2, so the sales revenue, greater than 60,000. Yeah. So that's one logical test, but we're saying we want multiple to evaluate multiple logical tests. Just looking at the chat, yes, you can use the formula builder in the exam. It does work. Yeah, it's a perfectly acceptable thing to do. And like I say, that's your big simplifier in the exam. Because you know, not everybody can write these formulas and functions by hand. That is your simplifier tool. So it simplifies the problem. You press, you just got to know which function you want. So I want an if function, press if in the formula builder and follow the steps. Yeah. So we've got this. So first logical test, the sales is above 60,000. Second logical test, customer satisfaction is above, well, it's 90% or more. So customer satisfaction scores are in C2. Now we've got a couple of options here. We can do greater than or equal to 0.9. 0.9 is 90%. Yeah, so that's one way we can do it. And I'll show you the other way in a minute. So they're the two logical tests that we want both of those things to be true. Now, if both of those things are true, what are we going to do? So we need to close the bracket after the two tests, comma, value if true. So I want, it said £1,000 elite bonus if both of those things are true. So just type 1,000. Then comma, what we're going to do if they're not true. So if either sales revenue is less than 60,000 or customer satisfaction level is less than 90%. If either of those two things are not true, or both might not be true, what do we want to do? Well, we don't want to pay a bonus. Yeah, so the bonus will be 0. Close brackets. Press enter, and you will see, in that case, we've got no bonus. Now, we do have a customer satisfaction score over 90%. So we do have a customer satisfaction score over 90%, but sales revenue is less than 60,000. So they're not both true, so therefore there's no bonus. Now, I said there's multiple ways to do this. Another way we could do it, instead of putting greater than 0.9, we could just put greater than or equal to 90%. And that'll do the same thing. Yeah. Now, if I copy this downwards, you will see that where they're true and where they're false. I can't see how to do it, and if in the formula builder will this need to be done manually. If you can't, I mean, all the functions are available in the formula builder, but if you can't work out how to do it, what I always say to students is, if you genuinely do not know how to do you don't know how to do the formula or the function that's required in the exam, if you just don't know how to do it, but you know what the answer is, type the answer in. Just literally type the number in. Now, that is not the answer, is it? Obviously, because they want you to do a formula, but you're going to get credit for the fact you know the answer. So it's better to do that than to do nothing. Because there's usually marks for the actual function or the formula, yeah, and then there's marks for the actual answer, the correct actual number. So if you can't do it, just so that was the second one. So we can see we've got some here where we're paying the elite bonus. It's where sales revenue is more than 60,000, customer satisfaction level is 90% or more. We're going to do a very similar thing now. We're going to nest an OR function within an if to work out whether or not there's any attendance review. Yeah. So employers are flagged for an attendance review if their customer satisfaction score drops below 70% or sick days exceeds 5. Write a formula to output flag if true, pass if false. So flag it for a review or pass no review. So we're going to do something very similar. So I'm going to do this one using the formula builder. Yeah. So we've got an if statement. So that's what I'm doing. And in that, I've got a logical test or brackets. Yeah. C2, which is the sales revenue. Yeah. Less than, not sales revenue, or C2, customer satisfaction score, is less than 70%. So I can type 70% or I can put 0.7. Yeah. So it's one element of it. The other element of it is the number of sick days needs to be more than 5. Yeah. If number of sick days is more than 5, then we're going to flag it. Otherwise, we're not. So number of sick days is in D2. D2 greater than 5. If that's the case, what we're going to do? Yeah. So we're going to value if true, flag, value if false, pass. There you can see, yeah, that one passes because customer satisfaction score is not less than 70 and we don't have more than 5 sick days. Copy it down. We can see we do have a few here where we do have issues. Yeah, so this one here, yeah, 85% customer satisfaction, which is above 70, but they had 6 sick days. So there's a flag there. There's a flag here because 65% customer satisfaction, not being off sick, but 65%, it's one or the other. Yeah. And then final one on this then is a round down function. So the round down function, so what we're going to do here is going to calculate a 2.5% commission on total sales. And then we're going to wrap it in a function. It says wrap your calculation in a function that forces the result to round down to the nearest whole pound. So we're going to take this So we're going to put equals in here. We can do it many different ways. You can use a formula builder, or you can literally write it out. Equals sales revenue. Yeah. So we can do this two ways. You can either work out what 2.5% is. Yeah. So we'll do that. So 0.025. That's, yeah, 2.5%. Yeah. Now, 2.5% of that is that number. Yeah. But let's see whether, yeah, so we can do that. But then what it wants to do is round it down to the nearest whole pound, which that is in pounds. But if I did something really balmy, like change that to 9, yeah. So sales revenue is now 55,009. Commission, that is literally 2.5%. It's not rounded. It wants us to round it down to the nearest number. So what we need to do then is check the calculation we've done and wrap a round down function round it. So it's going to be equals round down brackets that number that we've just calculated. Yeah. So B2 times 0.025, 2.5% of sales revenue, comma, number of digits, 0. And what that'll do is it round it to the nearest number, he says. I've done wrong there. I've got too many brackets. That's better. Right. So that gets me what I want. That is to the nearest number. However, it says 0 decimal places. Yeah. So we need to use the decreased decimals to get rid of the remaining decimal places. Yeah, so we're going to press that. We've got 3 decimal places here, so we'll press it 3 times, get rid of all the decimal places. And then if we just copy it down, yeah, we'll see that that has done what I want it to do. Yeah. Anyone got any questions about any of that sort of logical functions stuff? No? Right. Let's switch back to the slides very briefly. Yep, so we've done this stuff. Yep. Next thing I want to look at then is lookups. Now, I can only briefly remember, first time I ever looked at Excel, and I went, and someone showed me lookups, and I was like, you know what, that's pretty nifty, isn't it? I can think of thousands of things that might be useful for. Because it allows us to look up values, and then on top of that, the second bit of what I want to look at is all this what-if analysis. Now, that's what I've spent many, many years doing. Well, what happens to, it's just the questions you get asked a lot by finance managers, finance directors, other directors in other parts of the business is, well, and especially when you're sitting in board meetings, if you get to that level, is, well, Dean, what's going to happen if sales increase by 20%, what will happen to our profit? Or what will happen if interest rates go up by 5%? What will happen if inflation gets to 10%? Yeah. So what we can use Excel spreadsheets for, and what I've definitely used them for in the past, is building models that allow us to answer those questions. Well, this is what will happen if this happens. So what's known as what-if analysis. So modeling dynamic scenarios. So it's saying, well, if this happens, that's what will happen. If this happens, that's what will happen. And now we've got decisions to make, haven't we? Yeah. So first thing we want to look at now, there's different types of lookup. Let me just get that out there. There's what's known as a VLOOKUP, stands for vertical lookup. There's a thing called HLOOKUP, which stands for horizontal lookup. And there's the big, brave new entrant to the lookup market, this thing called a ZLOOKUP, which can do both. AAT have not caught up with ZLOOKUPs yet. They do talk in some learning material, just talk about HLOOKUPs. Never seen it or never heard of it being in the exams, but it is in the learning content, so it, in theory, could appear on an exam. VLOOKUPs, the gold standard of lookups, been around for years, and it definitely is in the exams from what learners tell me. So VLOOKUP stands for vertical lookup, designed to search for specific value or specific identifier in the first column of a data table. And then from that row, return a corresponding value from another column in the same row. So we're going to look up a particular value. That'll identify a row within the data. And then we're going to return a value out of a column on that same row. Now, it's really powerful for bridging between multiple data sets, allowing us to pull, for example, standard material prices onto a transaction log. So we might have a log of transactions. And we know we've sold product ABC, but we might not know how much ABC cost, but we know we sold 500 of them. Well, if we've got a price list over here, the price of product ABC, we can look that value up. Which is what we're going to look at in a little while. So 4 arguments, and I've put 3 boxes on here on purpose. Before someone says to me, why is you only talked about 3 things, but you said 4 arguments? I'll explain. So lookup value, that's probably the most important thing. So what specific item or code are you trying to find? So we might be trying to find a particular material code, or a particular employer number, or a particular general ledger code, for example. We might be looking up some value. So what's the specific thing we're looking for? So that's our lookup value. The table array is where is the master list of values stored? Where is that? Now, I've said must be absolute locked, like absolute referencing. Now, that is my strong opinion. I mean, it doesn't need to be absolute referenced, but I'm going to tell you it's going to cause you problems if you don't. And I'll sort of demonstrate what I mean by that in a minute. And then the third argument is what's known as the column index. So which column holds the answer to your question? So you might be looking up a set of values. So say we want product ABC, and we've got a table array that's got ABC, product code, product description, ABC spanner, and then the third column might have the warehouse it's currently stored in, and the fourth column might have the price. Well, I'm only interested in the price, so I'm not interested in all the other stuff. So my column index would be column 4, the price, And then the final bit, which is my sort of 3.5, it's 4 arguments, but I've only got 3 boxes there, is do you need an exact match? Now, in 99.99% of cases, I want an exact match. I don't want an approximate match. I want you to look up the exact thing I'm looking for in that list. And if it's not there, tell me it's not there. Don't guess and give me some other answer. So we want exact matches. Now, certainly for everything you're going to do at AAT, you want exact matches. You don't want any of this brave world of approximate matches, because you're going to get some crazy answer that you weren't expecting. So I got this slide dedicated solely to that final element of the VLOOKUP, what's known as the false argument. So you can either write false or 0. So the final element must usually, I say 99% of cases, be set to false or 0 within any financial modelling that you might be doing, because what that does is demands an exact match. Now, I don't know who created Excel. Well, I do know who created Excel, Microsoft, but I don't know why they thought it was a good idea that Excel defaults to true. So if you leave this bit out and forget to do it, it's going to default to true, which is an approximate match, which, and I've seen this happen, will disastrously pull the wrong unit prices if it does not find an exact match. If it finds an exact match, all is well in the world. But if it doesn't find an exact match, you are going to get whatever Excel thinks is the closest match to that, and it will give you that number instead, which might be different from what the number you wanted. I mean, arguably, if it's not there, you want to know it's not there, don't you? Yeah. So the quickest way to prevent lookup errors, use the false argument in final argument in your VLOOKUP, false or 0. And then finally, what if analysis. So some of the things that I just want to talk about very briefly here is, and we're going to look in my example in a little while. I don't like hard coding numbers into spreadsheets. It's just a personal thing. I want Excel spreadsheets to have dynamic variables. Yeah. So instead of hard coding numbers like 5% inflation rates, I want you to be able to set an inflation rate, and the numbers will change based on the inflation rate, because that allows a level of what if modeling. So this is what the numbers look like if inflation's 5%. If inflation goes to 10%, this is what happens to the numbers, rather than doing the whole thing twice. Yeah. So instead of hard coding numbers, you can directly link it to a formula. Yeah, which we'll look at in a minute. And then it allows a level of risk modeling as well, doesn't it? So by locking individual input cells within an absolute reference, you can change that variable once and see everything else change. Yeah. So we'll look at what I mean by that as we go through this. So it brings me to my second example, or second activity, another made-up company, Delta Manufacturing. What we're going to build is an automated inventory valuation model. Now we're going to use, it's very simple, so don't shout at me about how we're not valuing the inventory at the lower of cost or net realizable value. We're just trying to make it really quite simple at this point. So it says there on my slide, it says you have a transaction log of 500 material requisitions. I think you'll find that I've actually put 100 in the spreadsheet, because I thought if we put 500, might be here all day. And what it does is my transaction log shows material code and the quantity we've used. The task is to securely link that transaction log to our master pricing sheet to pull in the standard cost and calculate the total inventory. Yeah. So the individual tasks, the 4 individual tasks that we're going to do, implement a VLOOKUP to extract the standard cost, ensure that the table array argument securely locked with absolute references before we drag it down, and I'm going to show you what the impact of not doing that would be. Calculate the total initial valuation, so quantity times looked up price, and then implement a dynamic what if column referencing the inflation input cell to model what effect inflation might have. So back to Excel. So what we've got is we've got 2 further worksheets. one called Delta Manufacturing Master Prices. Now, similar to earlier, we can't see everything that's in column B. So I'm just going to select all this and auto fit the cells so I can see everything. Yeah. So we've got a bunch of material codes. We've got 10 different products, material 1 to 10, material code, material descriptions, and some standard cost. Yep. So that's what we've got on the master price sheet. On the requisition sheet, again, we've got a similar problem with this. So let's just fit all the data on here. We've got a load of different material codes, and they are repeated, which they would be. There's just material requisitions over some period of time. Yeah, so we've got, I think if you go back to the bottom, there's 100 rows of data. So there is 100, yeah, there's 100 different rows there. We've got standard cost per unit, total valuation, and then some revised cost. And up here, there's some inflation input. Now, similar to before, inflation's measured in percentages. 0.05 is 5%, but I'm going to format that as a percentage. Yeah, to press the percent sign there, it formats it to a percentage. Right. So first thing we're going to do then, on this sheet, in the cell C4, I'm going to write a lookup to search for material code in the master pricing sheet and return the standard cost per unit. Yeah, so multiple ways to skin a cat. Press the insert function button, click on VLOOKUP. Lookup value, thing I'm looking up, material code. Table array, the place where we're going to look for it. So it's not on here, it's on the other worksheet. So I need to click on the Delta Manufacturing Master Price sheet, and we're going to select all of that data. Yeah. Now I'm not going to do any. I'm not going to do any absolute referencing for now because I'm going to show you what the impact of not doing it is. Yeah. Column index says which column out of all of that. Oops. Which column am I looking for? So it's column 1, 2, 3. So column 3. Yeah. Range lookup, we've said we always want that to be false or 0. Yeah. If I press done now, we will get a number in there. 150. So standard cost of material MAT005 is 150. Is that right? MAT005, 150. Right. Let me just copy this down, maybe 25 cells down there. Right. Problem. Yeah. Now what's the problem? Yeah. The problem is I've not fixed the reference on my data table array. So as I've copied it down, yeah, it's now looking up in different places. So the reason this doesn't work here is because it's actually looking at A7 to, oops, it's looking at master prices A7 to C13. So A7 to C13. So if we go here, A7's there to C13, that bit. But M005 is in row 6, so it can't find it, which is why we get that nasty #NA error, because it just can't find it. So what we need to do is, as I sort of alluded to, spoke about a few times, we need absolute referencing on this. Yeah. Now, you can type F4, or you can't type F4 in the exam. So in the exam, you need a $ in front of the A, in front of the 1, in this case, in front of the C, and in front of the 11. Yeah. But then copy this formula all the way to the bottom. You will notice that all those have now got numbers in. So what that's done is it's looked up this material code in this list of prices here, this little lot. And it said, find me, in the first row's example, find me M005. So find me that row. So it's found that row. And then it says, which column do you want? Yeah, we've got column 3. That's column 1. Oops, that's column 1. Yeah, that's column 2. That's column 3. So I want the value out of column 3. So that 150 there. And that's what we've got. Yeah. So total valuation. Yeah. Now this is where we got a user written formula. Yeah. Literally equals B4 times C4. One times the other. Fairly straightforward. Now we might want to format all of these pounds and pence numbers. Yeah, we might want to use some 1,000 separators on that, get it in pounds and pence. Might want to do that. Yeah. And then we'll watch. So that's just a very fairly simple VLOOKUP. If you wanted to type it by hand, you could. Yeah. So equals VLOOKUP. Look up that. So in this case, A5, comma, select all of that. Now for speed, I'm just going to fix these using F4. Comma, column 3, comma, 0 or false. Do 0 in this case. Yeah, and we get the same number. The next thing we wanted to do then was to, in the revised cost column, understand what the costs would be if, well, what the total, that should really say total revised valuation. Let me change that to slightly different. Revised valuation. So if we did, so what we're saying is if inflation goes up by 5%, what would happen to the valuation of, or what would happen to our cost? That valuation is based on cost right now. What would happen to the cost of our products if inflation went up by 5%? Well, they'd get 5% more expensive, wouldn't they? Yeah. But what would happen if it went up by 10%, 20%, 30%, 40%? Now, this is quite a simple example, but obviously with cost, cost is only one element of it. You'd have revenues at the other side. What you might be trying to do here is say, at what point does inflation erode margin to a point that it doesn't make sense anymore? Yeah. So you might have 40% margin, and you obviously can have your margin squeezed by inflation increasing, selling price staying the same. But you might be trying to model at what point would we need to increase prices. Yeah. So what we're going to do then is we're going to factor in that number, that inflation number up there, to work out what a revised valuation would be. Yeah. So the way I'm going to do this is I am going to take the total valuation. So D4, and I'm going to multiply it by something. Yeah. So I think what I probably want to do is multiply it by 1 plus whatever is in J2. So if I multiply it by 1, I'm going to get the same number I've already got. Yeah, but what I actually want to do is 1 plus 5%. So actually 1.05. So multiply it by 1.05. Yeah, which is what that does. So, yeah. So equals D4 times 1 brackets, because brackets 1 plus J2. Now, that, yeah, that's great. Yeah, but that's not great, is it? That's not great either, all that. Yeah. So this comes back to the whole idea being that we want to use absolute referencing in some cases. What we want, very much want here, is absolute referencing of the value in J2. So you can click in the formula bar next to J2 and just press F4. Yeah. Or we can manually write it $J $2. Yeah, copy this all the way to the bottom. Yeah. Now you might say, well, what's the purpose of that? Well, the purpose of that is I can see what's happening to my valuation, the cost or the valuation, if inflation is 5%. But what happens if it goes to 8%? Yeah. Now we've got what if modeling now. What happens if you don't include the headings? Nothing. So nothing. If you don't include the headings, nothing. I think it's just a creature of, I'm just a creature of habit. I select the entire table. I mean, arguably, as long as you've got the data in the table selected, then you'll get what you want. So yeah, so now you've got what if modeling. Yeah, so that's what happens if it was 12%. If you get to 50%, then yeah, 2%. Yeah, and it saves you writing the same thing 1,000 times. Imagine if you were doing this on paper. Yeah, if we had this much on paper, and then your boss said to you, Dean, what'll happen if inflation's 5%? We've got to go through every number, get my calculator out, go through every number, add 5%, yeah, and then walk back into office and drop it on his desk and say, there you are, that's 5%. And then he goes, I'll tell you what happens if it's 6%? And then you go all the way back to your desk, get your calculator out again, and do the same thing for 6%. Or you could take your laptop to his office and go, what number did you want? 5%. Right, they're the numbers. Here's the numbers at 6%. Here's the numbers at 10%. Yeah. And Cheryl, you're absolutely right. You would start looking for a job at a second request. Yeah, absolutely. Yeah. But you get my point. It is that this just becomes far quicker and far easier to do what if analysis in a spreadsheet than it does on a bit of pen and paper. Right, back to the slides just for the last few bits then. So I know I'm over time. That's about an hour and a half. I would very much like to thank everyone for attending, especially on this extremely warm June evening.